All right, perfect. Yeah, we can get started as soon as you go live. Right. Welcome again to this beginner level course on Introduction to Java and Object-Oriented Programming. And today, this is the 7th video in this lecture. And here we will be looking at the pillars of Object-Oriented Programming and how we can implement them in Java. So before we get into the content, another general reminder that this course is brought to you in association with newtonschool.co. So newtonschool.co, this is the website for that. The description to their site is given in the description. So please feel free to check that out. The benefit of getting yourself registered in Newton School and following the courses that once the course is completed, that is, you have completed all the videos in this course, you will be getting a certificate, as well as you will be able to follow the course and its subjects with the assignments. So for doing that, you need to register to the site if you are a new user. Then once you have registered, you will come to your dashboard. In the dashboard, you need to look for the more tracks. So in the tracks, you will just need to search for this course. You might need to, so here is a course, Introduction to Java and Object-Oriented Programming by Pratik Bhattacharya. So you can apply for this here. And once you have applied, you can see the videos, do the assignments, and also get a certified and also get yourself certified once the course is over. Okay. Going back, we will be looking into the content now. So today's module 7 is about the pillars of object-oriented programming. So far we have looked into what is object-oriented programming and about the evolution of object-oriented programming as to why it was required and why the programming paradigms shifted from a procedure-oriented programming into an object-oriented programming model. We also looked very detailed the details of classes. We looked at it in depth. We looked at what are methods, what are constructors, what are access modifiers, and we have also looked into the basics of Java. So currently, we should be in a shape of where, given a program in Java, you should be able to start the coding for it. This last two modules are a little advanced concepts where your basic programming skills should have been built by now. You should be knowing about object-oriented programming. You should be able to write about classes. Try to write various Java programs as well. So now we're doing some advanced concepts. We'll be learning some, industry level mechanisms and also some programming styles as to how you can code in Java, how you can design in Java specifically. For that, we need to understand that when we are doing object-oriented programming, what are the pillars of it, or what are the major benefits or style of coding that it is bringing to the plate? So there are four pillars of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. We'll be looking into each one of them into details. We'll first looking at a simple theory as to what exactly that one of these pillars mean, and then along with the definition, along with the theory, we'll also be coding. We'll be seeing that how exactly these concepts manifest into the Java programming language. So one of the first pillars that you have is inheritance, and when you want to do a lot of code reuse, inheritance comes into picture. That is, inheritance really helps you to do a lot of code reuse. It helps you to model the objects, that model the real life objects in a better way. So inheritance, just the term inheritance means that you are inheriting, or you are getting the properties or something or some other assets from a particular person. Now this is or from a particular object actually. So if we talk about inheritance in real life, when we talk about something like property inheritance, like let's say a kid might inherit the property or some attributes from their parents. So that is like you are getting some, like there are certain things that your parents already had, and now the child is also inheriting, or the child is also getting those properties from the child's parents. So that is what inheritance is. It is like getting some attributes from some other object. And inheritance, when you look into, especially into object-oriented programming world, that is also exactly the same thing. We have got a concept of a parent class, and we have got a concept of a child class. And the child class acquires the methods and fields of a parent class. Now, if we need to give a real example or an example of that in the real world, let's consider two types of employees. Okay, one type of employee is, let's say, a full-time employee. Another type of employee is, let's say, a part-time employee. Now, there can be certain some differences between them, but there will be a lot of things which will be alike. Like, for example, as a part-time employee or as a full-time employee, both of them will be paid salary. So that is common between them. But as a full-time employee, you may be given certain extra benefits, like certain extra perks, which the part-time employee may not be given. Like, for example, a full-time employee may be given provident fund from the company, but a part-time employee may not be given because they are not, completely dedicated towards the company. So where we are trying to go from here is that assume you have got an employee class, that any employee we are saying will be given some salary. But there are different types of employee that you have here now. One is a full-time employee, one is a part-time employee. So both full-time employee and part-time employee, they inherit the behavior or they inherit the property of being paid from the employee. However, there are certain differences. A full-time employee will have an extra field called provident fund benefits, which the part-time employee is not going to be having. So here in this example, the subclass here is the part-time employee and the full-time employee. They are the subclasses, and the superclass or the parent class from which they are both coming from, which from both they are intending from, that is the employee class, which is the parent class. So this is what the concept of a subclass and a superclass is. And we'll be taking another example, which a more real life example, probably we can talk about it. So square, rectangles, circles, they are all shapes. So every shape has certain behavior, or every shape has certain property. Like, for example, I can say that every shape has some color. Okay. So square, rectangle, circle, they are all shapes. So they all have colors. And where are they going to get the color property from? They're going to inherit from their parent shape class. So if you've got a shape class and then you've got a square class, the square class inherits the properties from the shape class. This exactly is what is called known as inheritance. So when we were talking in object-oriented programming that classes and objects, they might have special types of relationship between them. This is also a very specific type of relationship. This is known as a relationship. Like square is a shape, rectangle is a shape, circle is a shape. So this is known as a relationship. So inheritance is all about this is a relationship. Now, although square, rectangle, and circle, they are all inheriting the color property from the shape, but they are also going to have some of their own properties. For example, the square will have one side. That's it, right? It just needs a one side. Nothing else is needed. A rectangle will have two sides, and a circle doesn't have any side. Circle just has a radius or a diameter, whichever way you want to represent it. So circle, triangle, and square, at their level, they all have different properties. Like one has a side, one has a height and a width, one has a radius, but they all have one common property, which is color. So this is so the color property that they are all reusing from the shape class, but then they have some other behavior, or they have some other properties which is their own. That is, they are not sharing with the other shapes. Let's see this in example, or let's see this in code actually. And for the code also, we will be going into the NS editor, the Newton School editor. So in the playground, you need to create a playground head, and I'm calling it as, let's say, pillars. Pillars of hoops. Let's choose the language as Java. Okay, all right. Now, first we need to do is we need to create a shape class to this. So class shape. And what would we say about the shape class? We said that the shape class has got something called a color. So I'm going to give, let's say, public string. Public string color. Okay. And let's just have something like public void display name. I'm not going to have anything else. And in this, in display color. So display color. And here I'm going to do system.out.println color. Okay. Nothing else, simple. Now let's write a circle class, or maybe we'll start simple. We'll write a rectangle class here. Okay. So the rectangle class, we are saying that the rectangle class is a shape itself. So rectangle and the shape, there's a relationship. Is a relationship. So rectangle is actually inheriting from shape. So how do you extend? So how do you show that in Java? For that, we need to use something called the extends keyword. If I write something like this means that the class rectangle extends shape. This means that the rectangle becomes a child class and it is inheriting from the shape class. Okay. So now rectangle already has the color property. Since shape has a property called color and shape has got a method called display color, rectangle automatically has both of them. Okay. So let's and to show that example, let's first write a constructor. And for constructor, what exactly a constructor? We just did it yesterday. So let's say I'm going to do color is equal to red. Okay. Then let me write my main class here. And what I'm going to be creating is I'm going to create a rectangle here. So let's say I'm going to create a rectangle R1 is equal to new rectangle. And in the constructor, I need to pass a string. I need to pass the color. So sorry, my bad. So I'll pass the color as it's a white. Okay. And then I'm going to do R1 dot display color. Let me just simply try to run this and see what happens. So just white is printed, or maybe I'll probably do it this way. Color of the shape is probably this will make it a little more intuitive. So your printing color of the shape is white. Now, if you look closely, I created an object of type rectangle. Now, rectangle does, and I'm calling for that particular object R1, I'm calling the method display color. But if you see closely, this rectangle class doesn't have a method called display color. So where is this display color coming from? This is where the parent class comes into picture. Since rectangle is extending from the shape class, or it is inheriting from the shape class, every method that the shape class had and every attribute that the shape class had, the rectangle class has access to it. The rectangle class will also have its own copy of it. So when you're actually creating an object of type rectangle, it will not only have all the attributes and properties of the rectangle class, but it will also get all the properties and the methods of the shape class. That is why r.display color is working. Okay. Now let us try to say that so rectangle is going to have its own properties also as well. Like it is going to have a height, G-I-G-H-T, sorry, and it will also have a width. Okay. So let's take those values as also input, height and width. So I'll say height is equal to height and width is equal to width. All right. And then maybe write a method here which will just going to calculate the area of the rectangle. Okay, calculate area, and the area of a rectangle is width into height. So it will return height into width. And let's have another method also. We'll call it as calculate perimeter, and this will be 2 into height plus width. Alrighty. So now R1 is there, and so rectangle we need to not only pass the color, but we also need to pass a height and a width. So let's assume the height of the rectangle is 3 and the width of the rectangle is 5. Then I'm going to do R1. Maybe I'll just print this out directly. Dot println R1 dot calculate area, and on similar terms, I'm going to calculate perimeter as well. We go ahead and run that, and I print that. There it is. So the area is 15, and the perimeter they're saying it is 16. Okay. So with that done, and now what we have done is we have done a single headedness kind of a thing. That is, we have only created a rectangle shape which extends shape. On similar terms, I can create another shape as well, and let me create a circle. So calculate a called, let's say, circle. And circle is also a shape, so it extends from the shape. Now, what is the property that a circle has? So circle has a radius. So I will take t as a radius. So let's do the constructor here. In the constructor, I need to take the color, and I just need to take the radius. Okay. So here, color is equal to color, and radius is equal to radius. So now rectangle, as you know, for a circle also I need to calculate the area and the perimeter. So the area, so for area for a circle is actually pi r square. So pi is 3.14 into radius square. So it will be radius into radius. And the perimeter is 2 into pi into r. So 2 into 3.14 into radius. Okay. So now that we have done that, let me create a circle as well. So probably just to ensure that I understand the output properly, I'll just say this is a rectangle. And this is a circle. Let's change all this. Circle C1 is equal to new circle. Let's give the circular color of red. Let's assume the radius is something like 7. So now this is all C1, 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 and let me run this, and you will be seeing that we have now two shapes. One is a rectangle and one is a circle. So, and they have their values calculated and everything. All right. So this is a very simple example of inheritance of where you have got a shape class, and then we have created two different shapes. One is a rectangle and another is a circle, and both of them are extending from the shape. Okay. So, and what are they extending and what are they inheriting? They're inheriting the property color and the display color method. And apart from that, the rectangle has got its own method called height and width. Its own property called height and width, its own method called calculate area and calculate perimeter. Circle also has its own property called radius, but it is inheriting again color and display color from shape, and and it has its own method called calculate area, calculate perimeter. Okay, so that's a very simple example of inheritance. We will be doing a little more tricky thing here, but yeah, before that, I'll just take a look into the chat to see if there are any questions. Okay, no questions so far. That's fine. Again, people who are watching this live, if you have any questions, please feel free to put it in the live chat. Or if you want, or if you're not watching this live, you are watching it as a recording, please put your question in the comment section and we'll get back to you. All right, moving on. And now for so far what we have done is we have shown you a single inheritance, right? Like a rectangle extending from a shape, a circle extending from a shape. Now, what if rectangle is already inheriting from shape, and what if there is someone else who says that I am inheriting data from rectangle as well? Then what will happen? Then what is going to happen is that object which we create, or that class which we create, which is inheriting from rectangle, will get all the methods and properties of the rectangle. Along with it, since rectangle is inheriting from shape, that will get the properties of shape as well, that is color and display color as well. And let us try to create a practical example for it. So for the example here, what I'm going to be doing is I'll write something like this: class square extends rectangle. This, if you try to understand that square is actually a rectangle. Like if you take a rectangle whose height and width is equal, then that becomes a square. So square is nothing but a special type of rectangle, or rather I can represent it that way, that square is a very special type of rectangle. So if I can represent it that way, that square is actually a very special type of rectangle, that means square can inherit from rectangle, just that its behavior will be a little different. So what is the property that a square will have? So square will have only one property, that is, it is only going to have a side. It is not going to have a different width and a different height. It is just going to have a side. So let's just call it side for now. Okay. And here again, something interesting is going to happen. So I'm creating I'm creating a constructor, and in the constructor again, I'm expecting, let's say I'll be taking the color and I'll be taking the side. Nothing else is needed. I don't need to do the height and the width. Okay. So the question here is, or rather the interesting thing that we have here is, so I'm saying that a rectangle is nothing but a special, or rather, sorry, a square is nothing but a very special type of rectangle. That's all that a square is. That's the reason why I'm able to, create a square as an inheritance of rectangle. But rectangle has a separate height and a separate width. But square, I'm saying square has got only one side. So if a square truly has to extend or truly has to inherit a rectangle, somehow this height and width, the values of this height and width, they must be equal to the side. That is, whatever the square side is, I must be able to pass this value to the rectangle class and tell it, hey, you know what? The height and the width of this rectangle should be whatever the value of side here is. That is, I need to do that. So how do I do that? So see that your rectangle is taking the value of height and the width from the constructor. So somehow from the square's constructor, square has its own constructor where it's saying only the color and the side, nothing else. So somehow I need to pass this data. That is, I need to pass the side. I need to call the rectangle constructor from my constructor, from my square constructor. And when I'm calling the rectangles constructor, the value of color I will pass as is, no problem in that. But the value of height and width, when I pass, instead of passing different values of height and width, I'm going to be passing the value of side to both height and to both width. So the question is, how do I do that? That is, how do I call the constructor of a superclass? So square here is a subclass. So from a subclass, how do we call the constructor of a superclass? That's the problem. So the answer to the problem is in the question itself. Since from the subclass we're calling a superclass constructor, we just need to write the word super. And when you're writing the word super, that means this one will call the constructor of your parent, of this class's parent. And this class's immediate parent is rectangle. So this method will call this constructor. And what are the parameters that this constructor is expecting? It is expecting a color. So color will be easy. I'll just pass whatever color I have been passed here, comma. It is expecting the height and the width. And what is the height and the width of a square? It is side only. Both the height and both the width, their height is also the side and width is also the side. Nothing else is needed. Probably into side also. Anyway, that is not important here, but yeah. So if I pass height and width here, then what I can do, the methods like calculate area, calculate perimeter. Now this is a question. The methods calculate area and calculate perimeter. Do I need to rewrite it in square? The answer is no. You don't need to rewrite it in square because rectangle already defines that method. That how exactly for a rectangle, I'm going to be calculating the area. I'm going to be doing height into width, or for perimeter, I'm going to be doing 2 into height plus width. Square also, it is doing the same thing actually. Square also, it is side into side. Instead of height into width, it is side into side. But the only difference is here height and width both are going to be same for square. So the formula for calculating the area is going to remain same for square. And since square is already extending rectangle, that means square is already inheriting both the properties. So I don't need to write the same properties for square here. I can all reuse things. That is, this class is automatically getting to reuse the calculate area and calculate perimeter method of the parent class. So if that is the case, now let me try to create a square. Probably here I'll create. So I'm calling it a square. And what I'm going to be doing here is I'll say square s1 is equal to new square. And square also take two things only. It takes a color. That is, let's say the color is yellow. I'm going to give. Let's say 10 is the side of the square. And they all are going to be just s1, s1, s1. Now let me run that. And you've got a rectangle, you've got a square, and you've got a circle. And you see the square's area and perimeter, they are automatically getting calculated. So although I haven't written the actual method, calculate area and calculate perimeter in square, I can still call s1 dot calculate area and s1 dot calculate perimeter, because the calculate area and calculate perimeter is being inherited by the square class from the rectangle class. And the rectangle's calculation, area calculation and perimeter calculation is same for square. So this is the advantage of code reuse. That is, since for rectangle I had already defined calculate area and I had already defined calculate perimeter, there was no need for me to rewrite or copy the same methods again for square. I could have simply used them since I'm already inheriting rectangle. That is the advantage that I'm getting using inheritance. So this is one of the major advantages of inheritance, code reuse. That if you have got two similar objects and one object is just inheriting or it is just a special version of another object, I can use inheritance to inherit the common methods. And if there is anything special that I need, if there are any special differences that I need, I can write that in the subclass. And all other things will remain common as the parent class. And that is what you can see is happening here. I'll just take a pause and see if there are any questions so far. Rishabh, please zoom in your screen. Okay, I think then I'll increase the thing a little bit more. Okay. Okay, I've increased the font size. Thank you, Rishabh, for that feedback. So probably the font size was a little too small for people to see. Okay, I will go on with the next part of it. The next part of it is there is one thing we can see, and probably that is also another refactoring you can say that we'll be doing here. That is, see, both calculate area or these methods, calculate area, calculate perimeter, all the shapes like rectangle, square, and circle. All the shapes have the same method: calculate area, calculate perimeter, calculate area, calculate perimeter, calculate area, calculate perimeter. All the shapes have got the same methods: area and perimeter calculation. So what it means is that every shape that I create, rectangle, square, circle, rhombus, whatever shapes that I get, pentagon, hexagon, whatever shapes that I get in the future, they all must have a calculate area and a calculate perimeter, because every shape you can calculate the area and calculate the perimeter. So this calculate area and calculate perimeter, which I have created in individual classes, like in circle class, square class, and rectangle class, they should be present in the shape class. Because I'm saying that every shape must have an area and a perimeter, right? So every shape that I do, rectangle, square, circle, must have the calculate area and calculate perimeter method. So there is no point for me to define the method, or rather write the method in the individual classes at the individual object level. I can actually have the method in the shape class itself. But the problem will be the implementation is different. That is, you go into a rectangle and I see that the way the area is calculated is using height into width. If I go into circle, the area is calculated into pi into r square method. So the implementation is different. That is, the circle class and the rectangle class, they are calculating the area in a different way. But they both have that method. So they both have that behavior, but the way the behavior is, the way that it is implemented, that is different. So with that particular thought, let's go and understand the second pillar of this thing of object-oriented programming, and that is abstraction. So what abstraction says is that abstraction is about hiding the implementation, that is the details of the implementation. So you expose only the essential features of an object, and all the other details of how they're implemented, that should be hidden. If I come back to the shape example, so from the shape class, I can expose that, hey, you can calculate the area and you can calculate the perimeter of every shape. I can expose that feature from the shape class itself. But how they're implemented, that is the details of how they're implemented, that can remain in the individual rectangle, circle, and the square class. So that is exactly what abstraction here is. That is, if someone is using the shape class, they know that every shape must have an area and the perimeter. You are exposing that to the users, to the people who are calling your to the people who are calling your shape class and everything. However, the way they are implemented, that is for a rectangle, for a square, the way they are implemented, that is how the area is calculated, how the perimeter is calculated, that needs to remain hidden. So this thing in abstraction, so this concept of abstraction in Java is done using something called abstract classes and interfaces. We will not be doing interfaces in this class today. We'll only be looking at abstract classes and abstract methods. Now, abstract classes and abstract methods, if we go via the definition, abstract class means that for that particular class, you cannot create an object for that class, but you can inherit that class and you can create an object of the child classes. That is what an abstract class means. That if you declare a class to be abstract, you cannot create a direct object of that particular class, but you can create objects of the child classes which are inheriting from it. And abstract methods can be present only in abstract classes, and abstract methods also mean that if a method is declared as abstract, that means the method doesn't need to have an implementation. That is just a means of exposing that method. However, the child class, which is inheriting from that abstract class, that must implement the method. So if you try to relate this concept with the actual definition of abstraction, which says that you are only exposing the essential features of an object. So why an abstract class and an abstract method? You can expose the features, or you can expose what methods that object has. Like if I declare shape to be abstract, the shape class can have two abstract methods: calculate area, calculate perimeter. So everyone who's using the shape class will know there is a calculate area and a calculate perimeter. But you don't have to implement it in the shape class. Why do you don't have to implement? Because the implementation will differ. Based on who is inheriting from the shape class, the implementation will differ. For a circle, it is, as I said, pi r square, and for a rectangle, it is height into width. So the implementation is hidden there using the abstract class and abstract method. And then when the rectangle, square, and circle, when those classes are actually defined, you're inheriting from the shape class. And that is where you need to actually write the details of, calculate the perimeter or calculate area and stuff like that. Let's see this into action. That should make the concept better, more clear. So you see both the rectangle has got calculate area and calculate perimeter method. Square, I'm not writing the calculate area, calculate perimeter method, but since square is extending rectangle, that is, it is inheriting from rectangle, it is also going to have by virtue of inheritance, it is also going to have the calculate area, calculate perimeter method. And shape also has calculate area and calculate perimeter. Now, first thing that I'm saying is shape. Now, shape, I can make it to be abstract. That is, I cannot create a direct object of shape. Now, which is true. If you think correctly, you cannot create an object called shape really, because that is very vague in nature, right? Like, what shape is it? Is it a rectangle? Is it a circle? Is it a square? Is it a rhombus? What shape is it? You don't know. So you can't create an object of shape directly. However, what you can do is you can create a rectangle, you can create a square, you can create a circle, which are implementations of shape. Implementations of shape, or in the sense that they are all shapes. But there it becomes more specific what kind of shape it is. So for a shape, you cannot create a direct object because it's very vague in nature. It's actually, if I use the term correctly, it's very abstract in nature. That's the reason why we are calling that class abstract. Now here I'm saying that an abstract class can have abstract methods. So if I do create an abstract method, so let me make it public, and I'll say public abstract double calculate area. And as I said, an abstract class doesn't need to have a method, doesn't need to have a implementation of their method, because the child classes who are inheriting from the abstract class, they are going to be doing the actual implementation. So I can just simply write this statement and there will be no error. On similar terms, I can do something like public abstract double calculate perimeter. Okay. Again, the same thing. So now I'm saying that shape class must have a method called calculate area and calculate perimeter, and all the child classes who are inheriting from the shape class must implement the calculate area and calculate perimeter, which is already done. If you see, like circle already has calculate area and calculate perimeter. A rectangle also already has calculate area and calculate perimeter, so this will be there. Now, just to show okay, and if I run this example, this is all again going to run. There is not going to be any issue. It is running exactly. But let me just deviate from this a little bit, and let me go to circle and let me comment out the calculate perimeter method. Okay. And let me comment out here also so that there is no error here. So now what I've done here is that the circle, which is inheriting from shape, it has got the calculate area method as dictated by the shape. Okay, let me close this guys. As dictated by the shape class, but it does not have the calculate perimeter method anymore because I've commented that code out. Let's see what happens if I try to run this. So now the Java compiler is going to see that it's going to see the area circle class and see the area is circle is not abstract and does not override abstract method calculate perimeter. So what it means is that circle is not an abstract class. It is inheriting from an abstract class called shape, and the shape abstract class dictates that you must have a calculate perimeter and a calculate area, because every shape must have an area and a perimeter. But the circle class is violating that rule. Circle class is saying I am a shape, but I have only area. I don't have a perimeter, which is wrong, which is incorrect, because every shape must have an area and a perimeter. So if I uncomment this, and now if I run this, There shouldn't be any compilation error anymore. There is no compilation error anymore, and just a simple standard output. Okay. Now we will take it one notch up here, and what I'm going to be doing here is, see here, and probably let me delete this for a moment. Yeah, let me delete all this for a moment. Okay. Now I'm saying that since I'm dealing with abstraction here, that is, since I'm dealing with abstract classes here, I can create a shape, and I'm calling the shape, let's say, as rectangle. But I cannot write something directly like this, equal to new shape. And why can't I do this? Because shape is an abstract class. If I try to do that, see, the problem that is going to face is compilation output error. Shape is abstract, cannot be instantiated. That means shape is an abstract class. That is, you cannot create an object of type shape. Means you can create an object, means you cannot directly create an object of type shape. It must either be a rectangle, square, or a circle. You can't directly say new shape. So, but I can create a shape, but I can't, it has to be either a rectangle, square, or circle. I need to tell what shape I'm creating. That is something that I need to specify. For that, let's say I do equal to new rectangle. And again, I will go back to rectangle. Rectangle has three things: color, height, and width. So let me pass that again. So let's say I'll pass the rectangle color as red this time, height as 10 and 20. Now if I try to compile it, no error. I haven't painted anything, so there is nothing else, but no error here. And why is there no error here? Because now when I'm trying to create an object of type shape, I'm telling create a rectangle for me. I'm specifying. I'm not telling just create a shape, because shape you cannot create. It's an abstract class. It's an abstract concept. It's vague. You can't create it. That's the reason why we declared it as abstract. Now we can create it. Now if I take rectangle, now what are the things? Now should I look into the rectangle here? That what are the methods that the rectangle has? And I should not actually. I ideally should not be doing it. I should not be writing something like rectangle.height. This is incorrect. I should not be writing that. So if I run this, you will see that there might be errors here. There might be other errors. Compilation input. Rectangle.height, not a statement. See, the problem that is happening is rectangle has a height, but this rectangle is of type shape. Shape doesn't have a height. Shape only has an area and a perimeter. So here, instead of that, if I call calculate area, and I try to run this, no error, it is working fine. Why is this working fine? Because shape has, let me close this, shape has an area and a perimeter. So if I'm creating an object of type shape, at that instance, whatever method shape has, I can directly call it. So let me again try to the system.out.println here. Just do the calculate area, and I'll do a calculate perimeter again. Let me just run this. Yeah, working as expected. No issue anywhere. Let me just do a system.out.println to show that this is a rectangle. Okay. And on similar grounds, I'll be creating a square as well. So in square, when I'm going to be creating, I will give shape square is equal to new square. And square, if you remember, it just takes two things. One, it takes the color, and it takes the side. It doesn't take everything. So come on, my bad. Let's say 15. Again, I'll do square dot this, and I'll be creating again a shape of a circle. Is equal to a new circle. Circle will be, let's say, yellow with a radius of 14, and then circle. Okay. Circle dot calculate area. Circle calculate perimeter. Let me run this. Yeah, it's working as expected. There is no problem in it. So it is working as it's supposed to be. But the advantage that you get is you get the advantage of abstraction. That is, from your main method, you do not know how exactly the area of the rectangle is getting calculated, because you are only using shape. And shape simply tells you there is a calculate area and a calculate perimeter. Shape doesn't tell you how rectangle does area calculation, or how square does area calculation, or how circle does area calculation. So main method is abstracted from the details. This is known as hiding the implementational details. So abstractions, another name is known as also implements hiding details. Detail hiding is also something that abstraction is known as. Okay. I will let's move on to the next topic. But again, before I go to polymorphism, I'll just again see whether there are any questions. me see. Yeah, I don't see there is any I don't see there are any more questions. Okay, so let me go to polymorphism. So polymorphism, it's more of a theoretical concept here actually. So we do not have to or rather, like I can show the example right in abstraction itself. That in abstraction only we actually certainly showed the example of polymorphism, but you guys didn't realize it. So polymorphism means it's the ability for an object to take many forms. So what it means is that if you have created an object, and based on the data or based on some scenario, some situation, that object is going to behave differently. Okay, and the best example for this is here. So we have created three shapes: rectangle, square, and circle. You can see they are all shapes, like they are not different, like they are not different, like they are all shapes. However, when I call this shapes dot calculate area and this rectangles calculate area, they are behaving differently. The area of calculation for a rectangle and a square is different. Or probably maybe I'll not take rectangle or square, I'll take square and circle. That will be a better example. Both square and circles, they are shapes. They are objects of they are like circle and square, they are object of type shape. But when I'm calculating the area of a rectangle square, or I'm calculating the area of a circle, they're behaving differently. The area calculation, the mathematics behind the area calculation is completely different. So here I can say that the shape class, objects of the shape class, can take different form based on which type of shape I'm using. That is based on which type of the derived class I'm using here. This is an example of polymorphism. There are multiple other examples of polymorphism that we can do, something like method overloading as well. That is, one class can have two methods of the same name as long as their signature is different. So that is also a polymorphism. That is where you're calling the same method, but based on the number of parameters you're passing or the type of parameters you're passing, the implementation changes. That's another type of polymorphism. But again, we will not be going into details into it. Interested people, you can actually go and search about it, that what is known as method overloading in a class. Method overloading is another example of polymorphism. So there are multiple examples of polymorphism, but the basic idea is that if an object can take on multiple forms, then that becomes polymorphism. And here the one of the examples that we showed is both square and circle are type of shapes, are objects of type shape. But when I'm doing calculate area or calculate perimeter, the mathematical implementation behind them is different. So they are behaving differently. It is taking a different form. Square is taking a different form, circle is taking a different form, as it should be. But they are both objects of type shape. Okay. We'll be moving into the last topic, or the last pillar that we have for object-oriented programming. And this is, most of the time, this is a very misunderstood pillar as well: encapsulation. So encapsulation, if we simply go by the definition, it means binding of data and methods together into a single unit. That is, you're wrapping the data and the code such that they behave as a single unit. That is what encapsulation really means. But the way encapsulation is implemented is by data hiding. Now there is one confusion here. A lot of times, people get confused between what is encapsulation and abstraction, because they are both hiding something. Abstraction hides the detail. That is how the implementation has been done. That's what abstraction is hiding, right? Because we are creating an abstract class, and from an abstract class there are abstract methods. So the caller doesn't know that what is the implementation of it. They are hidden from the details of the implementation. But encapsulation, I'm saying, is encapsulation is simply data hiding. I'm hiding the data of a particular class. And let us try to see, I'll show you an example, and we will see that what is the problem if we do not do data hiding in the correct way. So let us create a rectangle. Let me comment out all this because you already have done it. Let me create a rectangle here. Rectangle, let's say I call it as rect is equal to new rectangle, and rectangle, as I said, it needs three colors. I'll say red. I'm going to give 5 and 20, let's say. That's the thing I'm giving. And then what I'm going to be doing is I'm simply going to be printing the area and the perimeter for that. Right. Let me go ahead and print this. Yeah, so the area is 100 and the perimeter is 50. That's okay. That's working fine and everything. Now let me do something. I'll say rect.height is equal to 10. Let me print the same thing again. See now, or maybe I'll just do the area because I think it's a little example better example. So I'm just printing the area. So first the area was 100 of this rectangle called RECT. And then the same rectangle RECT's area changed to 200. Now, should that be allowed is the first question. And why was it possible? It was possible because this height property of rectangle is actually public in nature. Height also used to be rectangle. It is public in nature. And public, yesterday when we were discussing about access modifiers, we saw public means it can be accessed outside of the class or even outside of the package. That means if you've got a rectangle class anywhere, and if rectangle is also declared as public, anywhere in your software, outside of the package or inside of the package, any other class, they can at any point of time take a rectangle and change its height. Now, should that be allowed? Ideally, it should not be allowed, right? I have already created a rectangle object. I've already created an object. How can I suddenly in the middle of the application, in the middle of the code, change the height of the rectangle? I cannot do that. I should not be allowed to do that. But the reason I'm being able to do that is because height has been declared as a public thing. Okay. So I'm not hiding the data. So in rectangle app, the data is not being hidden. The data of rectangle, like height and the width, that is the data which it is holding. I'm not hiding it. I'm making it public to everyone, and everyone can go ahead and change it. So the first thing that you can do, the very simple thing how we can solve this problem is we simply make it private. We make both height and width private. Now you see, if I made something private, and if you remember yesterday's video, we discussed that if a property is declared as private, then only the methods within the class can access it. Classes outside of this class or outside of this package cannot access the height and the width. Now, if I try to run this, let's see what is going to happen. I'm getting a compile output, and the reason is height as private access in rectangle. That means now, since I'm outside of the class rectangle, I cannot simply change the height. I'm outside of this particular. I'm outside of this particular class. Okay. So this is one of the ways you can do this, and this is actually very good. So what I've done here is I have added an access modifier in such a way that no one outside of the rectangle class can truly know height and the width of the rectangle class. You are creating a shape. So for a shape, I'm telling you, you can know what the area is, what the perimeter is. But you cannot go and see that, okay, since it's a rectangle, let me go ahead and change the height. You cannot do that. I'm hiding that. I'm hiding that data from you. Okay, so this is known as data hiding. However, there is another pattern to it, another extension pattern to it actually. So one thing that might happen is, yeah, although I understand that changing the height of the rectangle is not a good thing, but maybe there is no harm in exposing the height information to the outside world. That is, we can tell people, hey, you know what, this rectangle has got a height of this, okay, but you cannot change it. People may be interested, other classes may be interested. Boss, you've given me a rectangle class, I know what the area and the perimeter is, but can I know what the height of the rectangle was? Or can I know what the width of the rectangle was? They may ask you, they may say that I promise I'm not going to change it. I'm not going to modify the class without your permission, but can I at least see what the height and what the width is? So now the question is, what can you do in a situation like this? See, if I can make this public, but if I make this public, then the problem that happens is some other class might change it, which should not be allowed. So some other class might change it. That's the reason I'm not making it public. I'm making it private itself. But there is a valid ask from some other team or some other classes who says that I want to see what the height of the rectangle is. I'm not going to change it, but I want to see what it is. This is where this pattern comes into the picture. This is called getters and setters. I can write a simple method called, let's say, get height. And what I will do, I will return height. Yeah. Now see, this get height is a public method inside the class rectangle. That means get height can be accessed outside of this class as well. And get height is using a private private property of rectangle, and it can use it because we know that private can be accessed anywhere within, means by anywhere within the class. So get height is a method in the rectangle class. That's the reason get height is able to use the height property of rectangle. So that is how I'm returning the value here. Now, if I need to print the height, we can do something like calculate rect dot get height. Let me comment this out and let me see this. What happens? So no error this time. Yeah, 5. I'm getting 5. I'm getting the height of it. So this is a way of how, if you have declared a variable or declared a property to be private in nature, but you want to expose its value to the outer world, this is a very good example of doing it. These are known as getters. On a similar fashion, you have got setters as well, but we will not be doing setters right now because we are setting the value from the constructor itself. So we are not going to be doing setters here, but that's a more advanced concept. But we are showing getters here. So this is a way how, if you have declared a variable to be private, but you want that value to be exposed, this is one of the common methods of a common pattern of how you can do that. All right. So that's about encapsulation, and that's about all the four pillars of object-oriented programming that we have. So before we end the class, once again, I would like to take a look into the. So just 1 second. Let me see if there are any. Just give me a minute. Yeah, there are no questions on the live chat, so that's fine. All right, so I think with that we can call it a day today. Again, thanks everyone for watching the video, and I hope that you learned something from it. If you have any comments or any questions, please feel free to put these questions and comments on the comment section of this video, and we will get back to you. Once again, thank you for joining, and have a nice day. We will meet again tomorrow in a new video where we will be discussing about some class designs.